tell you. Alright, how's it going? Welcome to Gamedev stream number 8, I think it is. Today we'll get started on the third minigame, third out of 4 that we're adding to our different classes. Last stream we worked on a bit of juice for the minigames. We added some sound effects, particles, and as well as impact frames for the platform minigame, which I really liked. After that, I have done a little bit of work. One of the biggest changes I did, or additions, I guess, is I added support for giving XP and money at the end of the minigames. If you remember, we only had support for items beforehand, but now we can actually give XP and items, or money. On top of that, I have added a couple new items to the game. What we just got was the so-called Death Ring, which increases XP earnings for a period of time. So we also have a Gold Ring, which increases money. We have a bunch of items that permanently buffs classes until the next rebirth, pretty much. And then I do believe we added something else, I can't remember. We had the class boosts, Gold Ring, XP Ring, and Meaty Bone. Alright, this item reduces or increases damage reduction for a short period of time. If you're new to the stream, make sure to wishlist Gridle on Steam. There should be a link in the description if you're watching on YouTube. This is an incremental game where you manage a party to fight waves of enemies for you. And right now we're adding minigames to sort of add some content on the side that you can play while your party is fighting enemies for you. Right, so the minigame we're working on today is for the Mage class. We already have for the Knight and the Miner, and so now we're doing the Mage, and then lastly the Archer. My idea is kind of to do something like similar to, or inspired by Tetris, I guess. Like an arcade puzzle where you just try to line up blocks horizontally to get points. Because I think a non-movement minigame would fit now that we have the platform and the mining minigame. Both of them are kind of similar in the movement and whatnot. The only difference is really that you fight enemies in one and you mine ores in the other one. Yeah. Right. So let's get started. Start by creating our scene. Minigame. Arcade puzzle, we'll call it. There. So I guess what we do want to get started with is getting some sort of blocks. We might actually have some already here. We have these tiles. If we're lucky, we might have something here. I kind of want something that looks like a rune of some sorts. What if we do this? This could work, I think. If we do some hue shifting, this could actually work. So let's drag this into a sprite and see what we can do. We'll just copy paste this. I will open the hue slider. Yeah. What if we saturate it even more? Oh, yeah, this looks really cool. Let's do this. So let's maybe do some sort of cyan one. Like this. Yeah. Yeah. We'll do a cyan rune here. Asset sprites. Oh. Let's do cyan block. Do some cool purple color like this, maybe. Purple block. A red one. Maybe a yellow one. Oh. Do a green one, I think. Maybe dark blue. See if we can do pink one. And then let's do an orange one. I guess like that. I think they're all fairly distinct now. Yeah, I mean, you can clearly see the difference between them all. There's none that really blend into each other. Great. Let's set all of these to be multiple in sprite mode. We'll do no compression. Point filter mode. And then we'll need to slice all of these up. Maybe this yellow was a bit too greenish. It might be, yeah. I'll do this for now. So we have the basic runes done, pretty much. So let's start by... Not quite sure how to start this. I think we want to set up the basic shapes for starter. So let's do a T shape. Or let's do a simple one, an I shape. I feel like that's the easiest one to start with. So we have that here. And we'll create 4 game objects. We'll make that cyan, or do we wanna... I feel like cyan is good. Let's see how we can... This will look good even. -1 +2 +1. Yeah. So that's what it would look like if we do it this way. Of course, another way we could do it is sort of like this. And of course that's going to look much better. But it is more work. And what happens if a shape gets like sliced? If you know what I mean. Like if the bottom part of this object gets cut in half, it's just going to look like this. But yeah, I think this is better for now. So let's see here. This will obviously need to have a collider. Yeah, let's get started with the game manager. Make this a singleton. Oh. Right. I guess we'll do a tick enumerator for starters. So we'll do a private enumerator tick, game tick. Well, here we'll do yield return new wait for seconds, time between ticks. We'll define this to private float, time between ticks equals 0.5. Let's do that. And here we'll do while true. We'll do this, so we'll indefinitely run this loop. Or I guess while should tick, because when a player loses, for example, we don't want to keep ticking the game. What we'll do, should tick, we'll set to true. And we probably won't touch this for quite a while. Right. I think we'll do here public list game object possible pieces, or all pieces. So this will just be all the possible pieces that can get spawned, pretty much. So we'll have that. And why is this giving red? Oh, fixing a semicolon there. Of course. There we go. So I think what we'll do here is we'll have a falling piece script, which will be attached to the current piece that's actually being controlled, if that makes sense. And this one we have to make a singleton because of the actual property of singleton, meaning that it only allows one instance of a class, which of course we want. We don't want several pieces to be falling at the same time. So we'll do public static falling piece instance, and then in the awake method we'll do the singleton logic. If there's no instance, then it will be this object. Otherwise we'll destroy the object. There. I guess we want to get a reference to the sub pieces of this object. So we'll do private list of transforms. Transform or game object. I think we just want to transform. Sub pieces. New list of type. Transform. There we go. So in our start method, we'll do reach transform child. In our own transform, we'll add child, and we'll clear this list beforehand just in case. There. Then in our tick, I guess we'll do if our falling piece, if there is a falling piece active on the board, basically, we'll define another method here, public void move down, which will do the actual moving logic. And for now, all we'll do is transform dot position. We'll set, or we'll do minus equals. Oh, that doesn't work. Vector 3. Okay. So here we'll just do falling piece dot. What do we call it? Move down. Oh, instance dot move down, of course. There. So here we'll do start core routine, game tick. So that's the basic script done, meaning it should move a piece down. We'll give this, what do we call it? Falling piece. Oh no, that's on the wrong game object. There. Let's see. Oh. Right. So it's moving up because we're taking minus the down vector. We gotta do plus the down vector instead, of course. There we go. Great. Guess we'll want to do some form of basic input as well. Let's go into our update method. Let's define one. I guess let's do moving left to right would be the first thing, I guess. But how do we do that correctly? We can do get axis raw, but then we'll get That will be set for every frame that we're holding, like left or right. We could of course do if input dot get button down keycode dot a, or does that not work? Can I convert? Okay, so just a then, I guess. Or input get button down key code dot left arrow. Why is that not? Why is it forcing me to pass a string here? Let's see, get key down. Yeah, right, it should work. Oh wait, get button down. Right, I should do get key down, of course. Key code dot a. There. If that's true, and wait, falling piece. I guess we could do that on the falling piece. There's no problem with that, really. Yeah, I guess. So we'll do move left. Otherwise, if do else. Input get key down. We go. So move left, we'll just do exactly the same thing pretty much as we do in move down, but with a different vector. So we'll do vector 3 dot left, and in move right we'll do vector 3 dot right. Now let's see if we can move. Yes, we can. That's great. If I seem a bit tired today, I apologize. It's currently super warm here in Sweden. Or warm compared to what I'm used to. Right. I guess we'll do the floor now. We'll do some basic floor at the bottom that we should be able to stop once we hit. Let's do something like this. I guess we... yeah, let's just do it a single color for now. So we'll give this box collider, of course. There we go. So in our falling piece script, in the move down, or not in the move down, I guess in our... We'll make a general function called public boolean can move. We'll pass a vector 3 to offset, or yeah, let's just do offset. And so we'll loop through our for each transform subpiece in subpieces. We'll move through like all the different boxes. If overlaps subpiece. So we'll define another method called overlaps. Subpiece and the offset, of course, we need to do. If it overlaps, then we'll return false. Otherwise, we'll return true. So basically, we'll loop through each different square like this, and we'll check if we take this square, add some offset, does that overlap with something? And if it does, then we can't move there. So then we just gotta do the overlap logic. So we'll do physics2d dot overlap box all, or just overlap box should be fine for now. So what does that take? It takes a point, which is our subpiece plus the offset, subpiece dot position. It takes a size, which will do vector to 0.75 by 0.75. We gotta do new vector too, of course. What was the third argument here? An angle, 0. And that returns a collider 2D. We'll check if we hit something. If the hit dot transform, if our subpieces contains the transform of the thing we hit, then we'll return false, because that basically means we did a check on one square and it hit one of our own squares, and obviously that doesn't count as colliding. Otherwise, we'll return true. There. So now I think all we gotta do is I think we could even make a general move function here. We'll do public void move vector 3 offset. If we can move, then we'll actually do the moving, of course. So then instead we can remove all of these. Or I guess we don't need to remove them. We'll just do move vector 3 dot down. We'll do the same for these. There. Make this private. So with a bit of luck, this should now stop falling once we hit the ground. And it did. Of course, it's not perfectly aligned, but it did stop because the next step would have made it collide. So I guess we'll need to do... yeah. So minus 7.5 instead. see if we can define our walls and make sure that those also work properly. Ay, with caps lock. 5.5. Let's see if these... Yeah! We can't move out of this box either now, which is great. Of course we have to make these properly aligned with their objects as well. There. I think that's perfect. Maybe we'll do 5 instead of 6. Yeah. I think that's fine. Great. Of course now, once we hit the ground, there's nothing that actually makes this stop and spawn a new object and whatnot. So we'll do that now instead. I think in our move, we could do a Boolean return value, which states whether we actually did move or not. So we'll do return true here if we did move. Otherwise, we'll return false. Then in our move down, what we'll do is we'll save this value. Boolean move equals move down. If we didn't move, then of course we hit the ground, or we hit something at least that prevented us from moving down. So then here we can do the actual logic of stopping this piece from falling and telling our minigame manager that we should probably spawn a new piece now. So we'll define a new function. We'll call it main piece. What is it called? It's just called falling piece. Falling piece stopped. So we'll do arcade puzzle manager dot instance falling piece. Did we not? Oh, oops, we defined that in our minigame manager. Right, let's not do that. The falling piece stopped. We'll call that here. And then we'll also I'm not sure how to... We can just destroy this component, right? I think that's a proper way to just remove this component from this game object. Meaning this is no longer the falling piece instance, is what we're making sure. Let's see if that works. So now when we hit the floor, hopefully this component should get removed automatically. Right, it did. Great. And then we're also calling this, of course, falling piece stopped. So we'll do public void spawn new piece. We'll invoke this after some time, I guess. I think let's do time between ticks times 2, maybe? Just twice the time between the ticks. So down here we'll do game object random piece equals instantiate all pieces, and we'll index it with random.range between 0 and all pieces dot count, meaning we'll just take a random piece out of the list. We'll spawn it at spawn point, which is a reference we'll do, and with just quaternion identity, which means no rotation. So then we'll need to define public transform spawn point. Oh, there. Cannot convert transform to vector 3. Of course, we gotta do spawn point dot position. Go into our prefabs folder. Minigames, we'll make a new folder for the arcade puzzle, and we will keep an or create a prefab out of our eye shape. Give it to prefab, and we'll define a spawn point, which will be 0 and 10, I think. No, wait. Let's do 12. And then at the start of our arcade puzzle manager, we'll just do spawn new piece. I guess we'll just call falling piece stopped, because that will automatically do this function, or invoke it after 2 seconds. So now we get a piece spawning. We can move it around. It should stop. And we get a new one. Perfect. Now let's see if we can put them next to each other. Yes, we can. Great. I think another thing I would like to do is add support for speeding up the falling, pretty much. So we'll do another private boolean state here called holding down. It's up to false. Then we'll do if input dot get key down, key code dot down arrow, or input get key down, key code dot s. We'll do holding down equals true, and then we'll do the same pretty much. Else if we're holding, or no, it should be get key up, of course. If we release any one of these buttons, right? Actually, I think we'll do if get key. If we're holding down any of these 2 buttons, then we'll set it to true. Otherwise, we'll set it to false. So if we're not holding any of those 2 buttons down. So then our game tick will do time between ticks times. Are we holding down? Did I really just call it holding down? Yeah. Fast forwarding, I think we'll call it. Holding down, that's quite arbitrary. Fast forwarding, if we're doing that, then we'll do times 0.25, we'll try that. Otherwise times 1. That did not work. There. I think we'll do public float. No, let's not do that. Let's just see how this works. Yeah. So have some form of basic fast speed up. Yeah. I think we'll do speed it up a little bit more. 5 times speed instead of 4. Yeah. I think that's good. Great. So that is kind of the basic movement done. It's just the rotation, obviously, that we gotta get working properly. Of course, that does mean we might need to change up the sprites a bit. Because just rotating like this doesn't make much sense, does it? I don't think so. That's going to be a bit of a challenge, I think. Right, let's start. I guess we'll do a check for the lines now. So we'll actually check if there is a full horizontal line and give a score based on that. So we'll define a function. We'll call it private void check for lines, I guess. Check for lines, yeah. And then let's just gotta have a look at where we're actually checking. It will be on half. I gotta change the snap value first. Hold on. 2.5. There we go. So it's at like minus 6.5, and then we go up to minus 5.5. It's at the half values pretty much. So I guess we'll do. Did we get a reference to the floor? Does that make more sense? Yeah. I think it does, right? Like we'll give, let's see, level, create a holder game object for this. And we'll give it the floor and both the walls. And then here, in our arcade puzzle manager, we'll do public transform floor, right wall, or first left wall, I think, and then right wall. So then we can use that for all the different position values. I think so, right? We can just do like private vector to start check position. We'll set the start check position will be new vector 2 of or value. The x value will be our left wall dot x, and the y value will be the floor dot y plus 1, I guess. So x, that will also be plus 1. Oh, of course, position dot x and position dot y. So that will basically be how will this look if I do like that. If we have the floor, we take that position. That will be the y position, and the wall plus 1 will be the X position. So basically get the bottom left corner of where we can actually put a piece. So then we'll just do for integer I 0 while I is less than left wall dot lossy scale dot y, which means like the height of the wall, and then y I plus we'll do vector2 dot check position will be the start check position plus vector2 dot up times the I value, I think. So we'll start in the bottom corner and then we'll go up one, up one, up one, basically. Or is it? Do we wanna, No, yeah, I think that makes sense. Yeah. Right. So here we want to do some form of raycast, I guess. And check if there are X amount of objects that we hit. Let's start by making the floor properly. The width, 9. Okay. There. So if we have this at 9, that means the width of our entire board is 9 as well. So we can also do then private integer board width. I guess we'll set it to 9 as a default value. And we'll do board width equals an integer of the floor dot transform. It's already transformed, so lossy scale dot x. There. Hey man, how's it going? Hi, welcome. It's going pretty good. I'm doing a bunch of code for the arcade puzzle minigame. It's like it's going to be similar to Tetris. But I'm a bit exhausted because the weather is in Sweden right now. It's quite warm, or warmer than I'm used to, at least. So let's see here. I'm currently doing the actual checking logic for when you actually get a full horizontal line. I'm trying to get that working. So check for lines. We'll do physics 2D dot raycast all, maybe? Because we want to get multiple hits. We want to make sure that we got at least 9 or 9. Raycast all. Yeah, obviously it doesn't take 0 arguments. I want you to suggest. Why is it not giving me? Hello? Yeah. A semicolon, obviously. But why can I? Why did it stop giving me, showing me the signature? What function? Yeah, just. I know it doesn't take 0 arguments. Why is it physics 2D dot? Is it not raycast all? Yeah, it is. Raycast all. Okay, here. Origin and direction. That's all. Great. So the origin is obviously the check position, and the direction will be vector2 dot right. And then what can we give it more? Distance, which is great. So we obviously just wanted to do board width. What else can we give it? Layer mask. I don't think we care about a layer mask. Or actually, let's do a layer mask. That's going to make it much easier. So we have this. We'll give it ore. We have an ore layer mask. Yeah, let's just use that one. That is used for minigames already. That is just for another minigame. That is an ore. So let's do private layer mask, check mask, I guess. So we'll set the check mask. Close layer mask, get mask, or let's set it. Can we do just the numeric value? So 12? No. Get mask takes a parameter of strings. Okay. So we can never change that name really, or we're gonna run into some bugs. But yeah, there's gotta be a way, right? Can we not just pass 12? We can. But I think layer masks they're bit masks, right? So if we pass 12, it's not gonna be layer 12, it's gonna be whatever bit masks represents 12 in binary. Let's see, Unity set layer mask to layer number instead of the name. Name to layer. Okay, so we can do 112. Okay. Oh, right, because that's like a bit shift, I think. It just takes a 1 and shifts it 12 places. So that should work. So we'll pass the check mask here. And what other? Min depth, I don't think we need to do anything else here. We'll need to store the return value, obviously, which is a array cost hit 2D array of hits. But do not array cost hit 2D cannot be found. Right there. So I think we'll just check if hits dot length, is it not? Is it just length, right? Oh yeah, if the length equals the board width, meaning we have a full line, I guess then all we'll do is we'll just destroy that line, right? Yeah. So then we'll do for each array cost hit 2D hit in hits, we'll destroy hit dot game object, or hit dot collider dot game object, of course. We'll do int destroyed lines equal to 0, and we'll do ++ for that, because then obviously we need to once we have destroyed a bunch of lines, we'll need to move the other pieces downwards in some way. Yeah. Let's try calling check for lines for now, once a falling piece has stopped moving. We'll see if the base logic works. At least. Oh, and we haven't assigned the values. Need to give it the floor, the right wall, and the left wall. There. Yeah. Great. So that worked fine. Perfect. I think we'll do a what do we want to call it? Piece holder in here. And what we'll do is I guess we'll pass the game object here. So we'll just have it pass itself. And then in here, we'll do for each transform child in piece transform. So for all the like actual squares inside of this game object, we'll want to move them to be children of the piece holder transform that I just defined. Do public transform piece holder. We'll do what piece stopped. Oh right. So we'll not call that then, I guess. We'll just do this again. So here we'll do child dot set parent to the piece holder. We'll check for lines, right? All right. No, after this we'll just destroy what remains of the piece, because it's just going to be like an empty shell of a holder game object. So let's get the piece holder. So now we should see the pieces should start populating in here, and we should get rid of all these game objects. Yeah. Oh. All right. Yeah. We can't really. Guess we'll need to do something like this, because what we're doing is we're looping through the child game objects of the piece game object, and then we're inside of that loop, we're moving them, so they're no longer children of that game object that we're looping through its children, meaning that after we've done half of them, it's going to be done, even though there's still half left, because we moved. Like, we did one iteration and then we moved it out, meaning we kind of did 2 iterations, if that makes sense. Because while we're moving through the length of the list, we're simultaneously shortening the list in each iteration. So I think we need to do... Can we do piece.get... Oh, piece.transform.get... No. Get children... No. I guess we could just make a local copy. How do we want to do it? Let's see. Unity transform get all children. No, it is just... Transform.cost. Okay, maybe that works. Do list transform all sub pieces equals piece transform.cost. Transform and what else? Dot to list. Maybe? And then we can loop through these. pre-transform child in all sub-pieces. Yeah. Maybe that works. I'm really not sure. I've never tried this like doing casts like that. Yeah. That works fine. Perfect. So now they're all getting populated in here instead. And we're getting rid of all the like holder game objects. Great. Now let's see if we can get it. Yeah. Right, so let's start defining some new shapes, I think. What is that, 360 rotation? Huh. Let's do an L shape. How do we want to get that going? I guess we'll do, we'll do an O shape for starters. I feel like that's easier. We'll do here, right? Where's the center point? Yeah. There. Just so we get some variety going for now. Let's see if it randomizes it. We got the sign one. Yeah. This is a bit misaligned, I see now. Oh, yeah, that is... Wait. Right. Oh, no. Wait, if I just push these... shift them like that. That should work fine. Right? Yeah. That solved it. Great. Yeah. And now, of course, we're not actually moving these down at all. Which, of course, we gotta do. So I guess we'll loop through... Ay. So we'll need to loop through all the lines that we actually removed, right? And for each of for every line that we removed, we'll need to take all of the squares that are left, and we'll need to check, is this square above that line, right? If it is, then we'll move it down. Yeah. I think that's it, right? So instead of storing the number of destroyed lines, we'll do a private list of floats, I guess. Destroyed lines y levels. Make this a new list of type float, and then in here we'll instead do .add check position.y, I guess. Is that fine? Yeah, I think it should be. So then we'll do for each transform square in holder. What do we call it? The piece holder. For each transform piece in the piece holder. We'll iterate through the destroyed lines y level, I guess. Yeah. So we'll do integer steps to move down is equal to ay. Actually, at first, let's if the destroyed line lines y level, if that's empty. Is there no empty function for lists? No free. I'm not sure what that. I mean, yeah, we'll just do if count is equal to 0 then. If we didn't destroy any lines, then we'll just return. We don't want to do anything further. But if we did, we'll loop through the pieces, I guess. I mean, we could do line by line. How would we go about doing that? Yeah, I think it's cleaner to do it line by line. Let's see. So I guess we'll loop through this again. I follow the lost scale, the check position. We'll do hits here. And then for each hit, hit.collider.transform position plus equals vector 3 down times how many places down we should move it, I guess. So we'll need to check here. The positions to move down equals 0. We'll do some magic here. If that still equals to 0, then we'll just continue. We won't do any further check because this line we're currently at, we want to be moving down even. So here we'll do, we'll loop through the, for each float destroyed destroyed line in destroyed lines y levels. If the destroyed line is smaller than our check position.y, we'll move up then. Position.y, and then of course we want to do because we're comparing floats. No, I don't think we need to, because the only time these can match is if we're checking a line that's been destroyed already. And we won't move anything on the line because there's nothing to move. So I think this is fine. So if the destroyed line is less than the check position, we'll do positions to move down ++. And here we'll do positions to move down. So that's, it might seem a bit confusing here, but basically all we should be doing now is we destroy a bunch of lines and we store each Y level that we destroyed a line on. And then we loop through all the lines again on the board. And for each line we check how many lines below this did we destroy. And we take all the pieces on the line and move them down that many steps, basically. Maybe this will work. Fingers crossed. There's a, I gotta tweak this a bit. The spawning delay, it's too high, I think. We'll just do time between ticks. I think we'll actually decrease the time between tick a little bit. Let's do 0.35. Yeah. Much better. Let's see, let's do some, let's mess this up a little bit to make sure this functions properly. Yeah. I'll do like that. Let's see if we can get an eye block. There we go. Now, hopefully. Moment of truth, please. Yeah. I think that worked, right? What if we... So now what if we destroy a line a bit further up? What happens then? Then of course only the blocks above that should get moved down. Let's see. Yeah, it works. Great. Of course we're gonna want this to not do it instantly. We want to add some form of animation, but I think it's a good start, of course. Yeah, perfect. So let's add some score, I think. Let's do a text mesh pro. Let's make this canvas be scaled with screen size 1920, 1080. Score display. We'll set that to be top left, I think. There. There's a lot of, you can have a lot of scores. Score 0. What about now? Yeah. Let's make it a bit wider, I guess. Is that really it? score 0. So let's define let's give a reference to the public tmp.text, call it score text, we'll import using TeamPro. So of course we want to store the score, private integer score. I think we'll add score plus equals 10 for each line that we destroy. And then we'll do a function, private void, display score, and then we'll do score text.text equals score plus formatter, the format text score. The formatter class that just formats it to have is it prefixes? No, it will be suffixes, right? But like 100,000 will be displayed as 100k instead of 1 followed by 0 or 5 zeros. Oh, of course we gotta give a reference to the score display, and we gotta call display score at the end of all of this. I guess let's call that here. I think that's better. And while we're at it, let's make this to an I enumerator, which means we can add delays in here. So I guess we'll do, once we actually destroy a line, we'll do yield return new, wait for seconds, 0, or time between ticks, I think. Or not a function. What am I doing? There. Of course we can't do this return thingy then. Do it like this. Can you add multiple of these? Let's see. That's possible. Yeah. Seems like it. So then we'll do, we'll have to do start coroutine, check for lines. And then I guess at the end, why is that not working? Oh, it's gotta be a capital C. I guess at the end of this, we'll do, we'll invoke the spawn new piece method. So we don't do it until we're done, like animating all of the destroying and falling and whatnot. Let's see if that works. So now it should be animated. Yeah! And let's see if we're gonna spawn anything new. Yeah, we did. That's great. I did notice it's adding quite a lot of delay, and I think that has to do with let's see, we're doing, yeah, we're always adding this delay, which means even if we check a line and there's nothing to move, then we add the delay, so it's going to do a delay for each Y level that there could be a square on. So I guess we'll do if hits.length, if it's greater than 0, only then will we add a delay. Meaning we'll just ignore the empty lines. Now, let's see if that works better. Yeah. And we got a score of 20. That's great. And it doesn't look that bad when we like cut the shapes off. Doesn't look horrible. Yeah, I like it. I think let's just add a small detail here. Since this is the mage minigame, let's add a little mage at the bottom of the corner. Guess we could do this. Yeah. We'll do the mage display or mage window. We'll do some more stuff with him, of course, but I'm not sure right now what to do. Let's add a rect mask and let's add the mage under here. 40 times. Can we do that? Yeah. Flip him around. Oh, of course we gotta do the panel, the frame as a separate thingy. Copy component. Paste component values. We'll remove that component. Do frame like that. There, right? Of course we want to make him a bit bigger. Something like this. Yeah. Right. So now it's the dreaded rotating of shapes. Which is going to be quite an annoyance. I mean, let's get started. There's no point in delaying it further. So let's do if input.get key down, key code dot space will do. Rotate shape. Public void rotate shape. For now, I'll just try adding a 90-degree rotation and see what kind of bugs we encounter. I know there's going to be bugs, but let's do this for now. We'll do transform dot Euler angles plus equals new vector 3 0 0 90. That should be it, I think. We are going to get clipping issues and whatnot. But yeah, now we can actually rotate this. And we have a bunch of issues. Yeah. This is going to be a headache because we have issues like this, where we can clip into the wall. We have issues where the objects stop aligning properly when we rotate them, as you can see. Yeah, there's lots of issues with this, which is why I said that this is it's going to be annoying to implement. Right. Oops, my bad. Ay, ay, ay. I don't even know where to begin with this. Hmm. I do actually have... I have done this sort of game in the past for an unannounced project, actually, that I'm working on and off. So let me look through that real quick. How I did it over there. We have minigames. Let's see. So we have tick, whatnot. Where do we have the rotate? Check for row. Try side move. Can rotate block here. Let's just take this and see how it works. We have can rotate block. Oh right, I do the rotation and then I check for overlap. And then if there is an overlap, I just I mean, yeah. That's one way to do it. So basically, if there is an overlap, I just rotate it back real quick. So what is the is valid position? This I think we can define in the game manager. We'll do public boolean is valid position. If the x value is smaller than left wall dot position dot x, or if it's greater than right wall position dot x, or if the y value is less than the floor dot position y. Do floor layer mask. What would that be? Right. I guess we'll define another layer mask. Obstacle layer mask. One, 0 and 1, 12, I think like that. We do an OR, yeah. I guess there. where is the rotate here? If we can rotate, then we do this. Right. Now we can't rotate at all for some reason. Right. So there's probably a lot of layer masks and whatnot that we gotta fix. But let's see where we actually do the rotation. Okay, rotate. Where are we calling that? Here. And we do rotate. I mean, we just do. We are just doing that, which is it's weird that we can't do it now. For each, if it's a valid position, transform to rotate, return false, or if it's not a valid position. So what are we doing? If the position.x is smaller than left wall position.x, or if it's greater than the right wall, or if the y level is less than floor.y position. We return false. Otherwise, we do an overlap box at the position. And we check if it's an obstacle. Oh, right. I have different layers for like the live prop. I have different layers for that and the actual and the ones that have been unpacked pretty much. Right. So let's do live. Live piece. Guess we'll just call it. So we'll change all of these to be live piece. We'll have the check mask to be instead layer 13. And when we unpack these game objects, we do child.gameObject.layer equals 12. There. I think that should allow us to rotate our objects now. Right. And we cannot rotate them when they're close to the wall. Right, that's great. Of course, there is still the issue of they're not properly aligned yet. Which I do need to get fixed in some way. Hold on, wait. Could that be the issue? Or just a simple solution? If I just like, what if I just center these around the... This one is still not centered. I gotta do it like that, maybe? Yeah. Hold on. Oh. No, we still have that issue. But it is aligned properly. Wait, no! It's good, I think. Like, now they're aligned. All of them are aligned properly. Yeah. Almost. This one still needs a bit of work. Oh, right. I gotta move these also like that, I think. Ay, ay, ay. Okay, so we have... No, hold on. This is one, like, a big gripe I have with Unity. This is not the actual position of the game object. Like this gizmo here. Because look, if I move all the child objects a bit to the right, then this moves as well. But that should be here, right? It should be at 0, 0. I'm honestly not sure how to change that. Like, it should be possible, of course. Unity, make parent position gizmo always display actual position. Because I don't understand why it would display it as like a weighted or like an average sum of the children positions. Yeah, here. If you want to use transfer gizmo's position, I'm not. Yeah, it's using local position, it seems. Let's see. No, it's not doing it. Like, it's super annoying. It makes it really hard to see the actual anchor positions for objects like this. But yeah, it's correct here. It's not correct here. That's the issue. Like, I should move this, I guess, down one step. Nope. Still not correct. Wait, are we... The snap is set to 0.5. So why is the... All right. I'm moving the parent object. Of course, that's not gonna do anything. Let's do it like that. There. That should fix it, hopefully. As long as they're all aligned the same way, it's fine. We can do this offset thingy later. Yeah, okay, they're all aligned now. Which is great. So now we have 1, 2, 3, 4, 5, 6, 7, 8 instead. Right. So we need to adjust the board a little bit. We need to do the floor be... I think we'll do 10. There. And then all the code should actually get adjusted properly when we just change the board size. I think we're moving this one a little bit too much. Like the anchor is too far down the subject. Nothing happened. Why? That's weird. 7, 8, 9, 10. That's super weird. It should be like destroying them. floor the lossy scale, which is 10, yeah. +1, and we do +1 from the floor, so we should be starting here. Yeah. Did it happen when we changed the layer mask, maybe? Yeah, I think that's why. Right, the check mask. That should be just 12, I think, right? Because we don't right now. Yeah, that was the issue. We were checking the live pieces, and of course those aren't part of the entire line. They shouldn't be part of any piece of the line, I think. Let's see here. Yeah, there we go. Great. Right, okay, that was the straight line. We're going to adjust a little bit. I think that's better. Let's see. No, not the green one. Come on. Ay! No, that's that's horrible. That was even worse. Okay, so what? We have that. There, I think. Yeah, I think that's better. That should solve it. There we go. Yeah, that's what we want. Perfect. Great. Now the question is how we want to actually do the scoring and the rewards. Like the most obvious thing would be to give rewards based on how much you score. But we could also maybe do another mechanic where maybe you need to, like, each line you destroy contributes to like some form of magic for the mage. But to actually do it, you need to have a specific distribution of the different colors. So like you'll need maybe for the first request it's like you need 40% green and 60% blue. So you'll need 1, 2, 3, 4, 5, 6 blue in the line, and you'll need 4 of the green ones in the line, like this, what I'm doing right now. And then it could be, oh, you need 60% green. So then you'll try doing it like this. Do green. Do blue here. Okay, I want to do even more green. Come on, another blue. Like something like this. Yeah, oh, that's perfect. So then you get a lot of magic because you did that exact distribution. 60% green and 40% blue. And then maybe Oh, now you need 20% to green and 80% blue, and then you do this way. I think that could be a fun way to make it unique, not just like the same puzzle mechanic that everyone's used to. Yeah, I think that's the way I want to do it. But I think we'll get started on that then in the next stream, because I'm running out of time right now, noticing. But yeah, I think would be a fun mechanic, and then we could give score based on that instead. So I think for now we'll do we'll do a time limit and whatnot. We'll try to tie this together to the main game real quick. So we have the score display. We'll do time display. Maybe we'll do that at the top and then the score further down, I think. What was that called? The script that we used? It was like effect slot. No. Status slot. Yeah. Status slot, and that's using normal text, of course it is. I guess we'll do it as a normal text. Is it that one? I can barely see it. Oh. Let's see how we did this in the mining minigame. We had the mine manager, which we where is it? Status slot, time left slot. Oh. To use set to using system. There we go. Time limit in seconds we'll define. Time limit in seconds. What are we doing here? Right, we're doing a bunch of reward pop-ups and whatnot. Oh, my bad. Let's see. So right now I'm just taking codes from the mine manager. The code that is actually stopping the game and displaying like the reward pop-ups and whatnot. Getting some error here. Arcade. What do we call it? Claim last reward we'll need. which will just send us back to the game. Oh. I will need to set to using scene management. Get all rewards. Right. Oh, right, we have all of this too. Ooh, and here we also need to define our potential rewards, of course. There we go. We'll need to do a reward handler. I'm noticing now that there's a lot of repeated code. This could probably be extracted to like a minigame manager class. The reward handler equals new reward handler. No, what did we do? There. And then here and get all rewards. I think we'll do for integer I equals 0 while I is less than score, and we'll do an integer division by 100 I plus plus. So basically for every 100 score you get a reward. Get chance based on, we don't need that. We'll just do rewards dot add reward handler get random object. We gotta cast that to the drop bundle. There. So let's get our reward pop-up. Minigame here. Add it to this. Paste as child. See if it looks good. Yes. We have all the references that we need. Keep the reference here. Reference to the time display. Potential rewards will set to the blonde chest, the silver chest, and the gold chest. And then of course, much like we did in the mining minigame, we'll let's see here, time left. We'll add our own little leave button. There we go. And just to test this out, we'll do every 10 points, we'll get a reward. I think as a final step, we need to copy our sound player. Minigame arcade. We'll just paste this for now. Hold on, we got a null reference exception, status slot. Oh, we haven't set the text, right? Time left text there. Still a null reference exception. Oh, I guess we could do it like this. Hold on. Or no. Let's just do null text. So we don't get that. Or actually, no. Let's not. Let's actually just check it. If status. If it's not no, then we'll do it. There we go. We got the time display. Now let's get some points. $20. And we got 40. And now we close it. 2, 3, 4. And the reason these are white is because the money and EXP class has not been set. Which it will be obviously when you boot up the game in the right order. But yeah, that was giving me money and EXP. Right, so final step then. Minigame manager. No. Or is it? All right, we feed that into the party class. This is where we actually feed the name of the scene. So let's see what the exact name is. It is Minigame Arcade Puzzle. So that will feed into our Mage class in the Minigame scene name. And finally, we'll add this scene to our build index. There. I think that should do it. So now we should actually be able to open up this minigame. Let's see if that works. Mage, we can upgrade him a bit and we'll boot up the minigame. Yeah. Let's get some points and we'll see if it functions properly. Ay, 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 that's not what I wanted to do. Do this. Here we go. Close it. 1, 2, 3, 4. And we're back at the main game. Perfect. I think honestly we'll leave it at that for today. Partly because it feels like a pretty good milestone, and partly because the heat is like actually killing me here. I can't do much more of this, unfortunately. But yeah, pretty happy with what we did. We got like the basics of the third minigame done now. So in the next stream, I guess we'll do like the unique point system that I said, where we'll have a distribution that you need to get in the lines in order to get points to begin with. So you can't just get rid of lines, you actually have to manage the color distribution of the lines in order to get scored. So that's what we'll do on Wednesday, is when I'll do the next stream. I'm probably going to stick to the schedule of Monday, Wednesday, Friday from now on. So it won't be every day, but it will be pretty much every other day during the weekdays. Right, if you made it this far, make sure to wishlist Gridle. This is the game that I've been working on for the entire stream. It's there's a demo out on the web, on Crazy Games, but then the full game is going to be released on Steam. Hopefully this fall, if everything goes right. So make sure you wishlist this on Steam, and I'll see you all on Wednesday. Yeah, thanks.